Okay, so equal parts for fractions. The whole of a fraction might not be the shape like a circle or a square. It can be anything that can be divided into equal parts. So for example, I have a line segment, okay, and I can cut this in half, or I can make it into quarters. Same as this. I'm not sure if you recognize the second one, but this is a 90-degree angle, and I can cut this in half. So angles are something else that we can make into fractions. This container, I can fill it half full if I wanted to, or I can drink even more of it. I can divide it up into equal parts. You probably recognize some doing fractional parts with apples. You would have used this in younger years, like how many apples are red, how many are green, what fraction of the apples are red. And then we can use oranges. If you're baking or making stuff as well, you can use a container that can show like how much flour do I need. So I need half a cup of flour. We can also do problems with people as well. And we can say, you know, how many people are wearing red skirts. Okay, so we can do fractional problems with many different types of things. So with you guys, I could do a fractional problem with, you know, birthdays in July. So if I'm looking at just 5-2, and what would I need to know in order to be able to figure out what the fraction of birthdays is in July? Well, I would have to know how many students there are, which that would be the total number that we're dealing with of equal parts. So if I'm looking at 5-2, it would be 29. And if I'm looking at 5-1, it would be 28. Okay, and then I know I have Sophia, Noah, Selma, Lizzie, William, and Olivia in 5-2 that all have birthdays. So those are my fractional parts of people that have birthdays. So 6 out of 29 people have birthdays, or 6/29ths. If I'm looking at 5-1, I only have 2. I have Adam and Bauer. So I have 2 out of 28 people have birthdays in July, so 2/28ths. So you can do this with many different things. I could ask you the question, how many people in your family are over the age of 16? Well, if I look at my family, there's 4 of us, and only 2 of us are older than 16, so it'd be 2/4. So you can ask that question of your family as well. Now, if I'm looking at identifying fractions of sets, I could ask what fraction of these shapes are shaded. So shaded shapes, I have 2, so 2 out of 5 are shaded, so 2/5. What fractions are circles? There's 3 circles, so 3/5. And what fraction of the circles are shaded? So there's 3 circles, so 1/3 of the circles are shaded. If I'm looking at this next one, I can say what fraction of these shapes are shaded, and I have 1, 2, 3 out of the 5, so 3/5. What fractions are not? What shapes are not shaded? What fractions are not shaded? So that's 2, so 2/5. And what fraction of the circles are shaded? Actually, what fraction of the triangles are shaded? And I have, 1, 2, 3 triangles, and 1 out of the 3 triangles are shaded, so 1/3 of the triangles are shaded. And what fraction of the squares are shaded? I have 2 squares, and they're both shaded, so it would be 2 out of 2 are shaded. And what fraction of squares are not shaded? That would be 0 out of 2 are not shaded.